Phenol, when reacted with concentrated nitric acid, shows tri-substitution and forms 2,4,6 trinitrophenol, which is also called picric acid. Though the yield by the direct reaction is low, the reason being the phenol gets oxidized by the nitric acid. This can also be obtained by an alternate method, in which what we do, we react this with sulfuric acid. So what we get is orthohydroxybenzene sulfonic acid and parahydroxybenzene sulfonic acid, and this on then reaction with nitric acid gives us a good yield of nitric acid. So that's an alternate method. And the sulfonic acids, we know that SO3H group is a very good leaving group, easily gets replaced, so its oxidation doesn't involve then oxidation of phenol OH group, and that is what we can get the picric acid in good yield. Now let us see the second electrophilic substitution, halogenation. See, when phenol is reacted with bromine, like we are reacting it with bromine water, we get a tri-substituted product which is called 2,4,6 tribromophenol along with small amount of the HBRs. Now what is most important to note in this case is we are getting tri-substituted product because in the polar medium or in the aqueous medium, what happens is the phenol gets broken down to phenoxide ion, and this phenoxide ion, since is having what, a negative charge on the oxygen, therefore this species becomes what, strongly showing what, plus R effect, and as a result tri-substitution takes place. So therefore if we want mono-substituted product, we need to stop this dissociation of phenol to phenoxide ion, and that can be done by what? By taking what? Bromine in carbon disulfide or in CCl4 non-polar solvents. In non-polar solvents, since phenol doesn't break down into phenoxide ion, this reaction is avoided and we can have only mono substitution done like this. So we'll be getting what? Orthobromophenol, parabromophenol, and of course this will be the major product. The reason being it is more symmetrical, so we get this product. So that is how we can do shifting. Yes, if we want mono product, we can change the medium into non-polar organic, and if we want tri-substitution, we can take it in the aqueous along with the in bromine in the aqueous medium or bromine water. Call-based reaction. In this, when phenol is reacted with CO2 in presence of KOH, salicylic acid is obtained. A very important reaction, a very important conversion, because salicylic acid is being used to prepare number of other compounds. So CO2's electrophilic addition takes place at ortho position, and what we get is salicylic acid. This salicylic acid on reaction with acetic anhydride, in what we can have is, because this is an acidic product, acidic substance, it reacts with what, your OH group in basic medium, it can give us what, an ester at the OH group place. So we get OCOCH3 and COOH. This is called 2-acetoxybenzoic acid called aspirin. So this is one of the product of the salicylic acid, which I have told you how it can be prepared by treating it with acetic anhydride. Since it's an acid derivative, it is going to react only with the OH group, not with the acid group. In basic medium, it results in the formation of 2-acetoxy. This is an ester group and acid group, benzoic acid. Ramadan reaction is another named reaction, a very important reaction of phenol, in which what we find is when phenol is reacted with chloroform in presence of KOH, what we first get is this compound, which on hydrolysis, because KOH taken is aqueous, the two chlorine are replaced by what? Two OH groups. OH. Now this results in the loss of what? One water molecule. So this gives us what? OH, CHO, called salicyldehyde. So the formation of salicyldehyde from phenol on reaction with chloroform and KOH is called Reimer-Tiemann reaction. Again, a very important name reaction of phenol. Let us see another reaction. It is the reaction of the OH group of the phenol, which is called reaction with zinc. See, it is the only reaction of the OH group which phenol shows. Phenol on heating with zinc dust gives us what? Benzene and zinc oxide. It's a redox reaction where zinc gets oxidized, phenol gets reduced. So what we get out of this is benzene. A very important reaction, especially from conversion point of view, because we get the benzene back. Let us see the oxidation of phenol also. Yes, phenol can also be oxidized using ammonium dichromate, sulfuric acid to the products called benzoquinone. And the same compound is formed with by the slow oxidation of the phenol when it is exposed to air, or when we have old samples of phenol, slowly they get oxidized to benzoquinone and they acquire color.